Welcome to this lecture. So in this lecture we will understand symmetric relation. So guys, by definition, a relation R on set A is said to be symmetric relation if A comma B belongs to R, implies that B comma A is also belonging to R. That is, you can say that if A is related to B, then it will imply that B is also related to A, where A comma B both belongs to set A. Like for an example, a relation R which is of this type. Say set is A 1, 2 and 3, right? This is the set. Then relation R which is of this type, say 1 comma 2, 1 comma 3, 2 comma 1 and 3 comma 1. Alright, then if you see the beauty of this relation, you can see that here A being 1 is related to 2. Alright, and this 2 which you can call as B is related to A as well. Similarly, this being related to 3 is related to A as well. So this is what this definition is trying to say, that if A is related to B, then B should also be related to A. That is 1 comma 2 and then 2 comma 1 both should be there. Similarly, if 1 comma 3 is there, then 3 comma 1 should also be there in the relation R. Such a relation is called a symmetric relation. And if you try to find the R inverse of this relation, you will see that in R inverse we reverse everything, right? So this will be written as 2 comma 1, this will be written as 3 comma 1, this will be written as 1 comma 2, and this will be written as 1 comma 3. Alright, so you can see that for a symmetric relation, R inverse will always be equals to R. Alright, so another thing you can see it, a relation R is symmetric if its inverse is equal to relation R itself. Make sense, guys? Such a relation is called as symmetric relation. Like for an example, a relation equal to is symmetric relation. Why? Because if A is equal to B, then obviously B will also be equals to A. Like if I say that 1 is equals to 1, I already imply that this is also equals to this. So 1 is equals to 1, right? So a relation equal to is a symmetric relation. Alright, guys? Similarly, if we see another set, A equals to 1, 2, 3, it says R consists of ordered pairs x and y such that x and y belongs to A and x plus y should be less than 5. So guys, if you see this, then you can clearly see that if x plus y is less than 5, then this will also imply that y plus x should also be less than 5, right? Because we just interchanged x and y, but still it's an addition, so it doesn't affect the addition. This means x and y and x, both kinds of ordered pairs are possible. Like if I see here, what will be the ordered pairs of R? You can see that 1 comma 1 will be there because 1 plus 1 is less than 5. 1 comma 2 can also be there. 1 comma 3 can also be there. And then 2 comma 1 can be there. 2 comma 2 can be there because the sum of all of these is less than 5. And then 2 comma 3 can't be there because the sum is equals to 5. And 3 comma 1 will be there. 3 comma 2 will be there. Alright, so now if we see here, 1 comma 1 is here, 2 comma 2 is here. We don't have to write again because 2 comma 2 when written again in different order, it will again be 2 comma 2 only, right? So we have to write it just once. And now 1 comma 2 is here, so 2 comma 1 is also here. 1 comma 3 is here, so 3 comma 1 is also here. By the way, this 3 comma 2 will not be there because 3 plus 2 is equals to 5. It's not less than 5. Alright, so this will be the relation R which is to satisfy this. Alright, so here you can see that if 1 is related to 2, then 2 is also related to 1. If 1 is related to 3, then 3 is also related to 1. Here 1 is related to 1, but we cannot write 1 comma 1 again, because if I write another element which is 1 comma 1 or another element which is 2 comma 2, it will be actually the two same elements, so we don't have to repeat them. We can just write them once. And you can also check by writing R inverse. If I write R inverse, I will get 1 comma 1, this will be written as 2 comma 1, this will be written as 3 comma 1, this will be written as 1 comma 2, this will be written as 2 comma 2, and this will be written as 1 comma 3. So we can see that R inverse and R are both same in this case also. Alright guys, clear with the concept of symmetric relations? Alright, makes sense?